So today I want to talk about the course infinite limits and the limits at infinity. At first, we should make sure that we will talk about the determining vertical asymptotes properties of infinite limits and the horizontal asymptotes in our class. Firstly, we will make the definition like a limit in which f of x increases or decreases without bound as x approaches c is called an infinite limit. An infinite limit or limits f of x when x approaches to c is equal to negative or positive infinite and do not exist. We just say that the limit equals infinite so we can be more accurate in describing how the limit doesn't exist. This is because a limit must equal a constant number. Next, this is an example that first to learn to determine the vertical asymptotes. First example is f of x equals 1/2 times x minus 1. So we can make sure that the denominator is 2 times x minus 1. When 2 times x minus 1 equals 0, we can know that the x equals 1. So the denominator is 0, and when the denominator is 0, we can know the vertical asymptotes. So the vertical asymptotes is when x equals 1. Then we could learn the limits, like when x approach 1 from right, we could use the number which very close to 1, like 1.0001, to know that the limit is positive infinite. And then when the x approach 1 from left, we could use a number 0.99999 like that to substitute the x in the function, and we can know in that period of time the limit is negative infinite. And the second example is 2/sin x, because when sin x is 0, the x we can know is 0, pi, 2 pi, like that number. Then the third question is f of x equals x to the power of 2 plus 2x minus 8 over x to the power of 2 minus 4. And we could use the method to make the function more clearly, like f of x equals x plus 4 times x minus 2 over x plus 2 times x minus 2. And we can see that there is a same factor in this function in the both denominator and numerator, like the x minus 2. So we could cancel this factor, and we will left the x minus 4 over x plus 2. So the vertical asymptote is when x equals negative 2, and so the denominator is 0. And because the numerator and denominator, both of them have the x minus 2, so we can know there is removable discontinuity when x equals 2. Then it is the properties of infinite limits. If the limit of f of x when x approaches to a c is infinite, and the limit of g of x when x approaches to a c is the number L, we can know that the sum of difference or the difference between the f of x and g of x, we could know that the limits of f of x plus or minus g of x when x approaches to a c equals infinite times plus the number L. So it could be seen as positive infinite. And second one is the product. And when the limit of f of x times g of x when x approaches the c equals the positive infinite times the number L. And in that period of time, when the L is larger than the 0, the final result is positive infinite. But if the number L is smaller than the 0, the final result is negative infinite. The third one is quotient. The limit of f of x over g of x when x approaches the c is it equals infinite over the number L. So we could see it, the result is the positive infinite. But if the limit of g of x over the f of x when x approaches the c, the number is L over infinite, because the denominator is infinite, so the final result is 0. So here is an example. If the f of x is 3x over x to the power of 2 times 1, we could draw this graph. So in this graph, we could see that when x approaches to the negative infinite, the function, the limit of f of x equals 3, because there is a horizontal asymptote when the y equals 3. So the final result is 3. Similarly, if the limit of f of x when x approaches to the positive infinite, the final result is also 3. Also, besides looking at the graph, we can also use the table to find the result of the limits. Like when x equals negative infinite, negative 100, negative 10, negative 1, 0, 1, 10, 100, also positive infinite. We could use a calculator to find the result. Finally, we could find that when the x gradually approaches the infinite or the negative infinite, the result is 3. And then we should find the limits of the function at negative infinite or at infinite finds the end behavior of a function. There is a theorem limits at infinite. If R is a positive rational number and C is any real number, then the limits of C over x prime when x approaches infinite equals 0, and also equals the limits of C over x prime when x approaches to the negative infinite. Here is the first example. When the limits of 2x minus 1 over x plus 1 when x approaches to the positive infinite, we could find that if we directly substitute x into positive infinite, we will find the final result is positive infinite over positive infinite, so we cannot evaluate it. So we should firstly divide x in both numerator and denominator. So then we could get this function that the limit of 2 minus 1 over x over 1 plus 1 over x when x approaches to the infinite. So this time we could know that 1 over x when x approaches to the infinite, the number is 0, and thus we could find the final result is 1 minus 0 over 1 and 2 minus 0 over 1 plus 0. The result is 2. Then if the limits of 3x plus 5 over 4 times x to the power of 2 plus 1 x approaches to the positive infinite. And similarly, we should firstly divide the x to the power of 2, and then we could get this function that's the limit of 3 over x plus 5 over x to the power of 2 over 4 times 1 over x to the power of 2 when x approaches to the infinite. And then we could get this 0 plus 0 over 4 plus 0. The final result is 0. If the limit of 5 times x to the power of 4 minus 2 times x power of 2 over 4 times x power of 2 plus 1 when x approaches to the negative infinite. Similarly, we should firstly divide the x to the power of 3, and then we could get limits of 5x minus 2 over x over 4 over x plus 1 over x to x cubed. And then we could get this. So it is negative infinite plus 0 over 0, and the result is negative infinite. Then we should find the infinite limits in the trig functions. Firstly, it's very common. We could see that the sin x. If we wanted to find the limits of sin x when x approaches to the infinite, we could not know for certain what the function is at when x approaches to the infinite. So the limits of sin x when x approaches to the positive infinite, it doesn't exist because of the oscillating behavior. Then, in order to find the limits of sin x over x when x approaches to the positive infinite, the square theorem using the 1 over x and the negative 1 over x proves the limit sin x over x when x approaches to the infinite equals 0. This is very important in our lesson, and we should clearly remember this function and the result, because when we learn later class, we will use this function frequently. And then we could use a graph to determine each value for e to the power of x and the natural log of x. If the function of x is e to the power of x, it is simple to find when x equals 0 or 1. So the result is when f of 0 is 1 and the f of 1 is e, which means it's about 2.718. And now we can find the limits when x approaches to the positive infinite. According to the graph, we could clearly see that when x increases, and the graph increases also either. So the limit of f of x when x approaches to the positive infinite, the value is positive infinite. Then if the x approaches to the negative infinite, we can find that the graph is gradually be close to the x-axis, so the value is 0. And then if the function g of x equals natural log of x, similarly we firstly find the value when x equals 0 or 1. Clearly we can know that the g of 0 equals the g of 0 we cannot, it doesn't exist, because even though the function gradually goes to the y-axis, but it still cannot intersect with the y-axis. So the natural log of 0 did not exist. Then the g of 1 equals natural log of 1. In the graph, we could see that the value is 0. Then we find the limits. The limit of g of x when x approaches to the positive infinite, it equals natural log of positive infinite. So it also is positive infinite. But if the limit of g of x when x approaches to the 0 from right side, we can know the value is negative. Value is negative infinite. Then we will talk about our homework in this course. Firstly, if the limit of 1 over x minus 4 when x approaches to the 4 from left side, we can know that in this period of time the 4 is vertical asymptote in this function, because when the denominator is 0, which means x minus 4 is 0, the x equals 4. So the limit is negative infinite. Also, if the x approaches to the 4 from the right side, the value is also positive infinite. Then if the limit of 1 over x minus 4 squared when x approaches to the 4 from the right side, from the left side, the 4 is also the vertical asymptote in this function, so the denominator is also 0. So 1 over 0 is infinite. It could also apply in the condition that when x approaches to the 4 from the right side. Then if the function f of x equals x to the power of 2 minus 1 over x plus 1, we can firstly make the x to the power of 2 minus 1 into x plus 1 times x minus 1. So we can find there is the same factor x plus 1 in denominator and numerator, so we should firstly cancel it. So we could get this f of x equals x minus 1. So because both of the numerator and denominator have the same factor x plus 1, so when x equals negative 1, there is a removable discontinuity. So then when f of x equals x to the power of 2 minus 2x minus 8 over x plus 1, we should firstly also make the x to the power of 2 minus 2x minus 8 into 2x minus 4 times x plus 2. So then we can find the function has a vertical asymptote at x equals negative 1. There is no removable discontinuity in this function because there is no same factor in both numerator and denominator. And then when the limit of 1 over x plus 1 when x approaches to the negative 1 from right side, we should find that when x equals negative 1, function denominator of the function is 0. So we could see that the value is 1 over infinite. So the final result is positive infinite. Then if the limit of x over x minus 2 when x approaches to the 2 from the right side, anything with the last question that the denominator is infinite, so the final result is the positive infinite. Then if the limit of x plus 3 over x to the power of 2 plus x minus 6 when x approaches the negative 3 from the left side, we can firstly regard this function as x plus 3 over x plus 3 times x minus 2. So firstly, we should cancel the same factor into the and we could get this 1 over x minus 2. Because the x approaches the negative 3 from the left side, we could find the final result is negative 1 over 5. When the limit of 1 plus 1 over x when x approaches the 0 from the left side, we could directly use x equals 0 and to replace the x, so we could get this the 1 plus 1 over negative infinite. So we can finally get it is negative infinite, because in this time the number 1 only is a small part of the infinite. So 1 over 1 minus infinite do not change a lot. So the final result is negative infinite. Then in your own words, describe the meaning of an infinite limit. Is infinite a real number? So an infinite limit is one that increases or decreases without bound as x approaches to z. Infinite is not a real number. Infinite is a set of real numbers, because we cannot exactly say what number is infinite. So the infinite is not a real number. Last question. Then the question is, write a rational function with vertical asymptotes at x equals 6 and x equals negative 2, and with the 0 x equals 3. So if we wanted to write a function that vertical asymptotes like that, we can know that there must have the denominator factors like x minus 6, x plus 2, like that. So the denominator is x minus 6 times x plus 2. If the function also have the 0 x equals 3, so x minus 3, this factor we should place in the numerator. So this is our final function for this question. Then for a quantity of gas at a constant temperature, the pressure P is inversely proportional to the volume V. What is the limit of P as V approaches 0 from the right? Explain what this means in the context of the problem. So firstly, we can know the limit of P when V approaches Z from the right side equals positive infinite. So as the volume of the gas condenses toward 0, the resulting pressure of the gas skyrockets upward. When the limit of 5 minus 2 times x to the power of 3 over 2 over 3 times x to the power of 2 minus 4 when x approaches the positive infinite, we could know this final answer is 0. It is same as we teach before in this PowerPoint. So it is very simple for this question. And then when the limits of 5 minus 2 times x to the power of 3 over 2 over 3 times x to the power of 3 over 2 minus 4 when x approaches the positive infinite, we could know that the answer is negative 2 over 3 because the x power is same, both of them is 3 over 2, so the limits we could see it as their coefficient before the variable, so that is negative 2 over 3. So if the prime of numerator and denominator is not equal, and the numerator's prime is larger than the denominators, and the final result is negative infinite. This question is easy because we have said before, and like when the limit of 4 times 3 over x when x approaches infinite, and we should firstly use x equals infinite, replace it into this function, so we could got this. It it is 4 times 4 plus 3 over infinite, because 3 over infinite is 0, so the final result is 4. It is the limit of 2x minus 1 over 3x plus 2 when x equals positive infinite. Because the prime of numerator and denominator is equal, so the limit of this function is their coefficient quotient, so that is 2 over 3. When the prime of numerator is smaller than the denominators, the result of the limit this function is 0. When the limit of 5x over x to the power of 2 plus 3 when x approaches to the negative infinite, the answer is did not exist. And then when the limit of x over the root of x to the square minus x when x approaches to the negative infinite, we will find that the prime of the denominator, we could see that the highest prime of the denominator is 1. And luckily the numerator's prime of variable is also 1, so that means the limit is the coefficient of the numerator and denominator, so that is -1. It is same with before's question, so it's clear that the answer is -2. And also it said that the root of x to the power of 2 minus 1, the highest prime of this numerator is x to the power of 1. And also the denominator's prime is x to the power of 1, so the result is the quotient to the coefficient of the denominator and numerator, so the answer is 1 over 2. And also the limit of x minus 1 over x to the power of 2 plus 1 to the power of 1 over 3 when x approaches the infinite, the answer is infinite or it doesn't exist. Then if the limit of 1 over x to x plus sine x when x approaches to the infinite, and we use the x equals infinite to replace this function x, so we could got this answer is 1 over infinite, which is 0. And it is seen that I said before that the limit of sine x over x when x approaches the infinite, the answer is 0. So it's the same for this question. We could change the function into the 2 times sine 2x over 2x. It is same with the function sine 2x over x. So because the sine x over x is 0 and the sine 2x over 2x is also 0, so 2 times 0, the answer also is 0. So that is what I say in this class. Thank you for your listening.